Hi folks, thanks for joining us today. We're going to be talking a little bit about a little thing called Kubernetes that some of you may or may not have heard of. We've had a really good response in terms of signups for this, so I'm guessing Kubernetes is something that most folks are interested in. It can be a touchy subject. There might be some people here who are very much beginning their journey. Some people who might be a little further along and they're kind of looking at ways to rationalize what's going on in their environment. So I'm joined here today by my colleague Tomáš, and we're going to just kind of give you a bit of a walkthrough where Kubernetes has come from, what you can do with it, where it's a good fit, where it might not necessarily be such a great fit, and from there we'll show you how you can leverage tools such as Runecast Analyzer to help you, gain compliance, make sure you're abiding by best practices, and all of that kind of stuff. As is always the case with these sessions that we run, we'd be more than happy to address any questions as we go through. But actually, if you could just drop them all into either the chat or into the questions panel, which you should see in your GoToWebinar panel, we'll either deal with them as they come in, or we've got a little bit of time left at the end, and we can address them then as well. So just a little bit of an introduction. For those of you who don't know me, I'm a senior systems engineer at Runecast. So it's my job to basically keep our salespeople honest. So I look after all of the technical side of the sales process, making sure people know how to use the tool properly, and just generally helping out, trying to make our customers' lives easier. Prior to Runecast, I was as a tech marketing architect for vSphere Lifecycle at VMware. So my background is very firmly in the vSphere side of things, but also I've done a bunch of cloud certs and things like that. So I like to keep myself busy with all kinds of new technologies. Outside of work, I like walking and Scottish football, travel, and cheese. I've not done any travel since February of this year, and it's really hurting me. But Corona is no fun game. You can find me on my blog at v-it.pro, and you can find me on my podcast at opentechcast.com, or you can find me on Twitter as @Kev_Johnson. Disclosure, before you just go there and follow me, it's not all about technology. So yeah, forewarned is forearmed. Tom, do you want to just introduce yourself?
Okay, I started in Runecast this year as a system engineer. And my primary goal is to automate stuff and work on Kubernetes. I was previously working as infrastructure architect in Europe's major retailer, where I designed systems and hardware, and was implementing them and servicing them. In my free time, I enjoy wandering on green fields and mountains, and with different kinds of means of transport. So that's
okay, cool. So you're another person who likes being up a mountain and running through fields and things like that. That's kind of cool. Okay. So I wonder what's going on with that. Never mind. So I'm just going to give you a quick rundown on how we used to do things, how we've been doing them in the kind of the model of virtualization, and then how containers play into that. So in the bad old world, when I first started working in the industry, way before we had the likes of vSphere to play with, we'd buy a piece of tin. It'd be a physical server, and we'd rack that, we'd stack that, we'd put it in the we'd get it ready to go. We'd install an operating system. Just the procurement of that server may have taken weeks or potentially even months, so it took a long time. Then installing the operating system, on top of that, you would install an application. And that's pretty much where you went, right? There's a problem here, or there's a number of problems, and these problems should be fairly self-evident. This process was expensive because every single application needed a separate piece of tin. And a lot of those pieces of tin, a lot of those servers were, they were woefully underutilized. They would sit there ticking over at 3, 4, 5% of capacity. So all of that extra capacity was going to waste. It was difficult to scale because every time you needed a new web server, you had to procure a new server, new physical server, install an operating system, install your application, and scale out was a real problem. And also availability as well, because it was so expensive. What would typically happen is customers and organizations would pull together and they would say, okay, well, we can only really afford one server for this SQL server. because buying another server is going to cost us way too much money. So they would skimp on things that would help in the the kind of time when you would have problems where a power supply would fail or a disk would go pop or things like that. So availability was a real issue, and availability plays into the CIA triad when you start talking about information security as well. So information security is also a challenge. So what we did from then is we moved on, and there was this thing called virtualization came to market. So we would still start in the same way. We'd get a physical server, we'd put it in a rack, and then we'd install a hypervisor. Rather than an operating system, we'd install this really, really super thin, super hardened hypervisor. And that hypervisor would then deal with carving up the resources that were available within that physical host into virtual machines. So we'd then provision a virtual machine. And then from that point onwards, it's very, very much like how how it was with physical servers. So we'd install a virtual machine, we'd install an operating system to it, we'd install an application or maybe a couple of applications to that virtual machine, and then we'd rinse and repeat. So we have lots and lots and lots of virtual machines running on the same physical hardware, and you get some extra benefits there in terms of you've got portability of applications. So a virtual machine can move from one physical host to another in the event that you have a HA event. So let's say your physical server fails, all those virtual machines restart on another server in the cluster. So you've got lots and lots of benefits there, but we still have a lack of agility. So in terms of, for example, if you have this HA event and that physical server fails, what happens is it's going to restart on another surviving host. But the process of restarting there, especially if you've got, potentially you're dealing with things like SQL servers and things that you might need to run some kind of recovery on a database, or you might even have a corrupt file system that you've got to repair. All of this means that even though it's been rebooted somewhere else, there's still an amount of downtime, and also scaling out can still be challenging. You still need to manage an operating system, so you still need to install that operating system. You still need to patch it on a regular basis because you don't want to be that person who's caught with the latest vulnerabilities. Also, they take a long time to boot. This is obviously subjective to it depends on how you want to look at it. So they take a long time to boot when compared to something when you look at things like containers. So containers, we start with a server. This server could be physical, it could be virtual, it doesn't really matter, but all we need is a server. We install an operating system. That operating system is typically Linux. There are Windows-based containers, but they seem to be a very, very small portion of the market. But we install this operating system. Then on top of that operating system, we install a container runtime. And this container runtime is what deals with giving the applications that run in containers access to that host operating system. So instead of each application sitting inside its own operating system, also on top of the hypervisor, it actually just gets a slice of that host operating system. And each container is super, super optimized. So it's only got the things in there that are required in order to boot and execute. And I think keep me honest here, Tom, if I'm overstating the situation. But yeah, this allows us to execute containers. And we have a number of problems here as well. So nothing's perfect is what we're saying. In order to run containers in an enterprise fashion, we need an orchestration engine. We need something to take care of making sure that you have the right number of containers, that you're pulling the correct images when you deploy those containers, that if you're doing an upgrade, you need something to manage the upgrade of those containers. The dynamic nature of this kind of environment, whereby containers can spin up and then they can die within a number of seconds, makes compliance checking super, super difficult, but it's also super important. It's very, very fast moving. So because it's very fast moving, again, we have this problem where it would be very easy without some kind of orchestration engine for someone to slip in something that's either by mistake or something that's malicious that could potentially cause issues within your environment. And the other thing about containers is, if you're going to be running these things in a production environment, unfortunately, it requires animal sacrifice. So you need to go out and slaughter a goat or something. And I'm vegetarian, so this is very much against my way of life. So why would we use containers? And so this is my cheap attempt to just get a reference into one of my favorite movies. It's also a terrible movie, I accept, but I loved watching The Matrix as a kid. And so there's this scene in The Matrix where when Neo asks about why would a program be deleted? Why would a container be killed? And there's any number of reasons why you might want to do that. It may be that something's crashed within that container, so something isn't working as it should do. And there's this old adage that's used widely now, where you have this idea of you have cats, you have pets and you have cattle. So if you've got a cat, like I've got sat right behind me right now, if your cat gets sick, you take that cat to the vet, you nurse it back to health, you spend a lot of money, a lot of time and energy making that pet feel a lot better, and hopefully it'll make a recovery. If you have a cow or you have a chicken, chicken's probably a better example, and that chicken gets sick, you take it around the back of the shed and you get rid of it and you get another chicken. And this is very much how how I like to look at how the differences between containers and virtual machines. With virtual machines, you install that operating system. If something goes wrong, you spend a long time trawling the logs in that operating system, maybe working with the application vendors, etc., to try and get that operating system, to get that virtual machine back to full health. Whereas with containers, something doesn't work, kill it, get rid of it. The other way you might want to kill a container is if you're actually doing an upgrade. So maybe you've got, I don't know, 10 containers running, and you want to deploy version 1.1 of those containers. You can kill one of those containers, deploy another one, and use load balancing features to point a relevant number of people at each one of those containers. And you can do these rolling upgrades then. So this allows you to just organize things a little bit better. And you can do these rolling upgrades. You can do A/B testing or red-blue testing, or however you want to look at it. And it just makes things a lot smoother when deploying these into a production environment. So Kubernetes comes along, and Kubernetes is not the first orchestration engine for containers. So there's been a number of other alternatives, but Kubernetes has largely won the war. And so it's important to understand that Kubernetes is an orchestrator for pods and not for containers. Now, in some cases, those pods in fact, in a lot of cases, those pods are going to contain a single container. Single container. Yeah, okay, right. So they're going to contain one container, and that's how you're going to execute them. But in some cases, you might want to have a pod that contains multiple containers, because you might have applications that have similar requirements, or maybe they need to share the same storage or memory spaces and things like this. You need them to communicate over a local host bus. In that case, you would deploy both containers into a single pod, and that's what Kubernetes handles. There's a number of container runtimes that we can use in order to be able to use Kubernetes. So we can use Docker. Docker's quite popular. There's Rocket. There's one called Cryo. Containerd is also very popular, and also one I discovered while I was researching for this webinar called Fracty. So there's you have a number of options when it comes to deciding how you're going to run Kubernetes, which specific container runtime you want, and obviously each one of these has their own pros and cons. So the choice is yours. Please do your research. And the great thing about Kubernetes is it really enables this kind of multi-cloud dream where you build once and you run anywhere. And those of you who've been in the industry a long time may remember that was pretty much the tagline for Java. So I'm really hopeful that Kubernetes doesn't become the new Java, because yeah, Java runtime was the bane of my life for a long time as well. It enables things like DevOps. So you can go and buy a box of DevOps. If anyone ever tells you that their job title is DevOps, ask them to explain it, because yeah, there's definitely people in the industry, and I would say I'm probably one of them. Whenever someone says to me I'm a DevOps engineer, I ask them what they actually do, and they just say DevOps. And it's kind of like the the Dilbert sketch that did the rounds about Kubernetes. DevOps seemed to be the one prior to that. So people would just keep saying DevOps, 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 and it meant a different thing to every person. And for me, it's more a way of working. It's a set of processes. It's how you actually make your applications run, and you take them from development into ops. And rather than having the tossing things over the fence. And if you're going to claim to have done DevOps, or to claim to do DevOps for your job, please have read the Phoenix Project at the absolute minimum. and then you get a lot more respect from folks. Kubernetes uses declarative deployments. So what that means is you build a document, a YAML file, and you toss that YAML file at what's called an API server. That YAML file describes exactly how your deployment is going to look, what it actually needs to look like as a finished item. It doesn't tell Kubernetes how it needs to get there. It just says, okay, well, I need this version of this application. We're going to have these tags, a bunch of different metadata, make it so, and we're going to have 3 copies of it, and we're going to deploy it in, to hosts that have these capabilities, for example. Declarative deployments, they're the future. And also the other kind of buzzword thing that we associate with Kubernetes is this idea of infrastructure as code. So you can deploy things, and you put all of this information out there, and the idea being that if you need to upgrade anything about your environment, you do it all using this declarative deployment, this kind of YAML-based method of deploying your infrastructure. And with that, I'm just going to, here's the this is what Kubernetes looks like, basically. So from that to that extent, what we've got is we have a number of nodes, and Kubernetes nodes are variously known as worker nodes or slave nodes, and some of these terms are not popular in the industry right now, so I'm just going to call them nodes. And a node is basically a server that is running a kubelet and a kube proxy. And kube proxy deals with the kind of networking side of things for those those container-based or those pod-based applications that are running. And the kubelet is the thing that communicates back to the API server and makes sure that that the API server is aware that it's there, it's ready to serve workloads, and it makes sure that the API server knows what capabilities it has. So each one of those is deployed in that manner. We have the scheduler. So the scheduler is the thing that actually takes the YAML files that have been sent to the API server and actually decides, okay, well, I'm going to run this many pods, so I'm going to run one here, and one over here. And if one of them becomes sick, then it's going to go, okay, we'll kill that one and we'll deploy another one over here. Or if we're doing an upgrade, again, the scheduler is going to come into account there. There's etcd, which is like a distributed key value store database. And again, Tom, if I'm getting any of this wrong, please shout out and correct me.
That's all right.
Oh, good, great stuff. I'm going to be a CKA in no time. And then there's the controller manager up there in the top left of the screen. So the controller manager manages the controllers, as you might expect. There's also the cloud provider, so the cloud controller manager. So if you're dealing with things like EKS or GKE, then you're going to be leveraging that. That's going to talk to the cloud provider API, and it's going to ensure that it's deploying things correctly on the cloud run instance of Kubernetes. So the API server is kind of it's where everything happens, and that's where we tag in as Runecast Analyzer. So we can talk to the API server, and we can pull a whole bunch of data back from there, whether that's data that's been persisted into etcd or data that we can actually query directly over the APIs. And from that, we can then say, okay, great, here's your best practices. We've analyzed you against these best practices, against these security standards, and from there, we can make recommendations about how you can improve your environment. That is about as much as I've ever had to speak about Kubernetes, Tom. So I'll let you take over for a little bit now, if that's okay. So can you tell me a little bit about where Kubernetes came from? What's the deal there?
Okay, so as you might probably know, Kubernetes was originally developed by Google. That started with search engines a while ago, but it evolved quickly and started implementing new services, and these services were running in containers since the beginning of this century. While they implemented the containers, as you mentioned, Kev, it's not variable to manage them separate, so they needed orchestration platform, and they developed their own orchestration platform that was called Borg. So that was the predecessor of Kubernetes, and pretty much looked similar, but
And this was an internal Google project, yeah?
Sorry?
This was an internal Google project.
Yeah, this was internal Google project that they have helped offer their services to the public. So when they came to a certain point of this project, they decided to make it public, and they started to work on Project 7 internally, which was called by 7 of 9, which is some Star Trek character.
So
like
Star Trek nerds working at Google then, basically.
Yeah. That's why. So the Project 7 name was kept in form of the logo, which contains the seven spokes on the wheel. And when they released Kubernetes in the public, that was in 2015, they also formed Cloud Native Computing Foundation with Linux Foundation, and put Kubernetes to public as open source.
Okay,
so
cool. It's only been around for 5 years, and now everyone's talking about it, right? That's pretty good.
And it's getting a lot of attention. It's getting noticed, and also a lot of companies are implementing the containerization, and mainly based on Kubernetes. And Kev, can you tell us why is that? Is that some great technology that everyone needs to jump on, or why do everyone?
Yeah, so it's an interesting point actually. I've just got one little nugget that I want to toss out there for the other folks, because I did a little research before this, and the word Kubernetes, I'm reliably told by Nigel Poulton, it roughly translates as helmsman, and that's why it's kind of like the ship, the steering wheel of the ship, and obviously you're putting the containers on the container ship, so it's all kind of. I thought that was a nice little nugget. It's going to come in handy for a pub quiz one day.
But yeah,
in terms of,
sorry.
Yeah.
It comes from Greek, and I also remember this. And one thing that caught my mind was that originates in the same roots of wording like cybernetics. So that was interesting to find out.
Okay, cool. That's a new one on me, so that's awesome. So in terms of why people are using Kubernetes, I think I've probably touched on it a little bit in the slides earlier, but it really allows us to operate these modern applications at massive scale. So if you want to run your workloads, part of them on AWS, part of them in some sort of on-premise infrastructure, part of them maybe in Azure, or on whichever cloud platform you like, Kubernetes can do that, because you have this kind of abstraction layer, and it's kind of like that abstraction layer for workloads. So that's kind of one of the main reasons. I see a lot of organizations that are using Kubernetes primarily for the development pipelines. So they're kind of CI/CD type stuff, whereby they're going to be building from source all the time, deploying that code, automated testing, and then once that's done, you don't want to have to manually create those virtual machines. You don't want to have to manually delete any of that stuff. So just throw that stuff, toss those YAML files at your API server, and it's going to deploy what you need, only what you need, to the exact specifications that what you need. And that's another really good use case. And the final one is really, it's just about scalability and availability. So one of the really cool use cases there is you can deploy things and say, okay, right, well, I need to make sure at any given point that I've got 5 copies of it running over here and 3 copies of it running over here, and Kubernetes will make sure that that is always the case, even if some of those containers get sick and have to be terminated. You're just going to get new known good copies that spin up from that, and that's kind of how I see. Other than obviously it's the new hotness, and everybody wants to talk about the new hotness. That's kind of where I see organizations primarily using Kubernetes right now. So off the back of that, what kind of workloads would you say are a really good fit for Kubernetes?
Well, mostly scalable workloads, or workloads that are already prepared as microservices, because they can be scaled very well. But in general, it can be any workload, but it might make more sense when it's not taken as it was developed before as a monolithic application, but is refactored and prepared as microservices, and then can be deployed to Kubernetes to leverage all their options that they offer.
Sure.
And
I guess part of that is, you know, because you have because of the fact that those containers can just be killed like that, you need to make sure that there's got to be some way of handling persistence there, right? Because all of these applications, all of these business logic applications, you know, the organizations are relying on to make them money, they all need to store data in some way. So how does Kubernetes handle that? How can they make this problem go away?
Yeah, you're right about that. In the beginning, it was mainly used as a stateless application hosting because the data was external. But these days, it's common that some of the workload that is deployed to Kubernetes is leveraging so-called persistent volumes that allow persistent storage, as it's called, persistent storage of data. So if the container needs to store the data, it will use the persistent volume, and when the container is killed and restarted, Kubernetes makes sure the persistent volume is again connected to the container.
Okay, cool.
There's several options how to do it. One way is to prepare these volumes in advance and then map it to containers. But more practical way might be using persistent volume claim that will allow you to dynamically create these volumes, and you just create something that's called a storage provider, or sorry, configure a storage provider and create a storage class that will allow you to create persistent volumes and use this storage class to create persistent volumes. So the storage class can describe the underlying storage in terms of performance or availability or anything you can imagine. And you will just describe in your persistent volume claim that this pod will need, I don't know, SSD only storage of 10 gigabytes. And via the storage provider, Kubernetes control manager will manage to create the volume and map it to the pod.
So, but the important thing is that when those containers are killed and a new one is spun up, that can be just reconnected to the existing storage so that you can handle that. And I guess that's going to be super important for you know, when people are starting to look at things like you know, the typical use case of lift and shift, where you're just going to take your existing workloads and put them in a container, right?
Yeah, that's definitely possible, and they will need to use persistent volumes.
Okay, cool.
So
yeah.
Yeah.
Go on, Tom. Go on.
Okay, I will ask you now. So we are talking about what workloads are best fit, but what about workloads that you already run in virtual machines or maybe on physical servers?
Yeah, so I guess the answer there is, you know, your mileage may vary. So some applications, you may be able to take those applications and just drop them in a container and execute them, and they're going to work. But I wouldn't, for example, recommend trying to run, I don't know, a Microsoft Exchange server in a container, right? That kind of stuff's not really going to be a good fit. So you need to really think about how your applications are put together, and in some cases, you know, you're going to have these big ugly monoliths, and those big ugly monoliths really they're going to be a better target to, instead of doing just kind of like lift and shift, you're going to want to kind of figure out, okay, what makes up that monolith? How can I break that into microservices? And would that then enable me to you know, handle things like availability and scalability in a better manner, and just kind of go from this kind of tightly coupled model to an incredibly loosely coupled model for those microservices. So yeah, you're in-house. Those applications that you've built in-house, if they're fairly simple, you might be able to just take them and run them in a container, especially if they've been designed with Linux in mind. But generally, you might, it's going to be one of those things whereby you're probably going to want to think, is it something that I can refactor? Can I turn it into a 12-factor app? Or do we have to maybe think about retiring this and going with something more modern in order that we can leverage Kubernetes for all of the reasons we've already discussed? So yeah, I mean, it's going to be, your mileage may vary. Give it a try. Don't just say, okay, we're going to, in 6 months' time, we're going to take all our applications and we're going to be running them all in containers, because that is not going to be a fun time for anybody. So yeah, I mean, hopefully that kind of covers off the how the applications kind of fit together and everything. But just to kind of focus a little bit more on in terms of what Runecast Analyzer does. So we provide, we provide the methods to be able to check against best practices and industry security standards. So from that perspective, who actually puts together the best practices? Who decides what's best practice for Kubernetes?
There are various sources on the internet, mainly blogs and articles. But what we used as a source of the best practices is the official documentation. It's all there, but it's not easy to dig through that and find all the pieces. But that's where
it's the
we
problem
are.
Runecast Analyzer solves for all kinds of
exactly.
as well, right? So yeah, lots and lots of documentation. Nobody really knows where to look. So yeah, I guess the Kubernetes website is where we would start. So that's kubernetes.io, right?
Yeah, that's the source we used for best practices. Currently, we have some of them implemented. With today's upgrade, knowledge base update, there will be some more, and we will be introducing the rest in the upcoming weeks. Can you maybe tell us about the security standards? You were mentioning we contain some already.
Yeah. So we've got the best practices there, and the best practices are best practices, right? So a lot of that stuff is kind of like you really should do this, and some of it is, you probably should do this, but have a think about your use case. Not every best practice is applicable to every organization. But when you start talking about security standards and compliance with those security standards, it tends to be a little bit more rigid. So, if you need to be compliant for a PCI DSS, for example, then you need to do everything that is listed in that standard. Now, as things stand right now, out of the box, we've got coverage for the CIS standard, the Center for Internet Security benchmark 160 for Kubernetes. Now, there's some other stuff that we're going to be working on, and hopefully you can tell me a little bit about that a little later, Tom, which will give us some extra visibility into what's going on. But in terms of what we're pulling back from the API server, it's the CIS standard is what we have right now. Moving forward, we're going to be adding more best practices, so pulling in more of those, this really good, high quality industry standard knowledge into the product. And again, this is just going to come down as knowledge-based definitions. So every week, if you've got your appliance connected to the internet, you're going to get the updates. There's going to be some new stuff coming in there. We'll be finalizing some stuff on CIS. As I say, at the present, we've got the stuff in CIS, coverage for CIS based on what we can pull from the API server. There's some extra ways that we can pull data in, which Tom will talk about shortly. But expect to see PCI DSS, NIST, and potentially a whole bunch of other standards coming into the product for coverage of container-based workloads running on top of Kubernetes. So I guess that's a good point where we could segue a little, Tom, and talk a little bit about how exactly Runecast Analyzer pulls that data from Kubernetes. So I spoke a little bit about the API server earlier, but can you just talk me a little bit through on how we authenticate against that API server, and maybe what kind of capabilities we can pull back?
Okay, so as you mentioned, we currently use the API server to fetch the data from the cluster, which allows us to implement like 60% of the CIS, but we are preparing to add more. I will just mention it in a while. With the API, we are connecting directly to the API server, either to the master node or using a load balancer. That depends on your environment, and we leverage service account that is created in the cluster, and our own role that requests gathering all different kinds of objects with read-only permissions. So we just use it.
So we're not making any changes there then. That's kind of important. We're not making any changes to.
Yeah, that's right.
We're just reading the configuration. Great stuff.
Yeah.
Cool. So yeah, so we have the service account token. We've got a role that we create. We create. I guess we've got documentation on how to create that role within the cluster.
It's part of the user guide how to easily achieve that and create a service account and use it to connect to API.
Awesome. I've done that a few times, and it is super simple. So that's pretty cool. And we're authenticating using this service account token. So there's no username and password. We just provide that service account token to the API server, and it already knows, you know, which role, which privileges should be granted. So I guess that kind of leads us on to the next question I've got for you, really, which is, you know, we're pulling all of this information from the API server. Is there any scope there to maybe go with like an agent-based model, and what would be the benefits of doing that if we did?
Definitely it will, because not all information that is required neither for best practice, neither for the security standards are contained only in the API, but specifically kubelet and node-based data will need to be read from the nodes. So we are currently evaluating the possibilities of implementing the agent that will allow us to collect this kind of data.
Okay, great stuff. So it's really just going to help us have a much more rich view of what's going on all the way across the environment, not just, you know, what we can actually pull directly from the API server, which is what we've got in this initial release. And, you know, it's kind of awesome that we've got that. So I guess watch this space on that front.
Yeah.
Awesome.
In terms of the findings and of the results of what is able to the Runecast Analyzer provide to the user, how the user will like step up for viewing the data or seeing the results that Runecast Analyzer is providing.
Yeah. Okay, I get you. I guess so from that perspective, we're providing the exact same kind of capabilities in terms of, you know, the historical audit data, so we can show you, you know, exactly what's gone on all the way across, you know, over the course of a year or more if needs be. We've got all kinds of reporting capabilities, filtering capabilities, and, you know, this is just an extension of what we already do with Runecast Analyzer. So if you've got vSphere in your environment, NSX, if you've got Horizon, if you've got any AWS native public cloud stuff, you know, we can give you all of this information already. We've been building these reporting capabilities into the product for years now. So we're just now adding Kubernetes to all of that really, really rich reporting capability. And I'll be able to show you that in a demo in a few moments.
Great. Okay, so
I guess the other thing is, you know, we've got all of this. So we've got best practices. We've got all of the security standards that we've already mentioned. We've got PCI DSS, NIST, GDPR. There's all kinds of standards in the product in terms of how we're reporting. But also just to kind of give you a little glimpse into the future, we've spoken a little bit about what's coming down the line in terms of you know, in terms of where we're going to be bringing extra stuff for Kubernetes. But, you know, watch this space. We should see in the not too distant future, we're going to be introducing support for NSXT. So if you're using NSX across, you know, your various different cloud providers, then we're going to have some capabilities there. We've had customers begging us for support for Microsoft Azure public cloud. So expect to see something similar to what we already have for AWS on Azure, and then logically, you know, the next step would be the Google Cloud as well. But yeah, so that's kind of where we're looking to go in the coming, you know, it's not necessarily going to be next week, but we've got a super aggressive roadmap. We're pushing out new application updates typically once a month, and, you know, so we can definitely, you know, there's definitely a lot to watch this space for. And on that note, I'm just going to very quickly show you how the application works. So Runecast Analyzer is a virtual appliance. You deploy it on premises to your to a vSphere environment. At present, we're looking at potentially, having capability to deploy natively to public clouds as well, and potentially even a container-based model. But at present, we deploy using a virtual appliance. Once you've deployed it, you point your appliance to some sources of data. So if I just come into the settings here, we can see in this environment here, I've got a bunch of different vCenter servers, some Horizon servers. I've got an AWS account. We can have many of these things, and now we can also add some Kubernetes connections as well. So in terms of the Kubernetes cluster, we need the API server address. So in this case, that's here. We go over the standard API server port 6443, and we need the service account token. So the service account token, the process to generate that is detailed in the Runecast Analyzer user guide. So we can come here and we can see these are all the privileges that we require. These are the verbs, these are the resources. But here's some, you can literally just copy paste this in at your API server. You can generate this service account token, and this, where are we go? This is going to kick out a service account token. You then copy that, you paste it in here, and once you've done that, you're going to be able to pull the details from your Kubernetes environment. Now, as I mentioned, we've got best practices in here for Kubernetes. So in this specific environment, if I just do a filter, you can see we've got coverage for a whole bunch of other things as well, obviously. But if we want to look specifically at best practices for Kubernetes in this environment, I've just got the 5 that I'm checking against. But that's cool. As Thomas said, we're adding more and more all the time. So I expect that these are going to be extended. And we show you where you pass and where you fail in those environments. And as with all of the other findings that we do, we show you exactly where your exposure is. So we can see here, we've got some containers that aren't using requests or limits, which is contrary to the best practices defined. And we can see it's in the Kubernetes dashboard namespace. So there's all of these different containers that are running. They don't have requests or limits assigned to them. We've got things like you should enable cluster auditing. So cluster audit, if you're not doing auditing at your cluster level, then it's going to be really tricky to identify why something has happened, how something has happened, and who caused something to happen. So you really should have all of these things configured. And again, we're going to show you findings. In this specific case, we don't have an audit log path or an audit webhook config file. You can do logging using either webhooks or writing direct to a log file, and that's not present in this environment. So all of these things are super important. And then from here we can say, okay, well maybe we want to actually only look at things that impact on security, and we can filter down further and we can see, okay, here are the 2 things that I have in this specific Kubernetes cluster. And remember, this is a tiny environment. In a production environment, you would see significantly larger volumes of findings, and also things that we're checking against. So here are the 2 things. Maybe we want to generate a report, and here we go. We're going to kick out a PDF. We're going to send this to our security officer, and there we go. We've got that. So we can now see these are the objects, these are the actual things, these are the actual findings on there. And then if you want to look at what you need to do in order to resolve these issues, again, we point you directly to the official documentation. So here's how to set auditing on a cluster. And we do that for everything that we do these best practices for. So vSphere, for NSX, for AWS, all of these things. We also have, as we mentioned, we've got coverage for CIS. So in terms of CIS, if we come down here, I've got the CIS Kubernetes Foundation. And yeah, we've got quite a few more findings in here. We've got 71 findings against this environment. Now, some of these require a manual check. So we can't always check these things automatically from the API server, but they're still best practices. So we're still going to flag them up to you. Now, you might want to you might want to look at some of these and say, actually, yes, okay, well, I agree that I have minimized the use of wildcards in roles and cluster roles. Now, minimize is entirely, it's going to differ from business to business, whether you have minimized something or whether you need to go further. So this is why we can't automate this check. But we can tell you these things. We can go, okay, we're going to do a manual check. We're going to select all of these objects, and then if we hit edit, we can say yes. We've either done the things that we need to do or we have not. And we can say also that, not only are we saying, yes, we've manually checked these things, but you should periodically review those things that you've manually checked, because just because something was manually checked a year ago doesn't necessarily mean it's still the case now. So you should really specify a date that that's going to expire on as well. And importantly, yeah, it's going to be applied to all selected objects. So, super important stuff within how you organize your Kubernetes workloads, and as well as any other workloads that you're running that Runecast Analyzer is providing coverage for. As I say, we have coverage for all these other different standards for different products. Expect to see more of these coming through for Kubernetes in the not too distant future. I do want to just touch on one other thing that we introduced in the same release. So we released Kubernetes support on the 30th of September, so it was a couple of weeks ago now at VMworld. And the other feature that we introduced at the same time was this concept of custom profiles. So we've got about 2,500 checks built into the Runecast Analyzer appliance. And most of those checks are going to cover almost everything that you need. However, we've got them bundled into these different profiles. So there's different security compliance standards. So for example, we have a lot of customers that work in the kind of military vertical, and they base their standards on DSysTig, but they also want to provide coverage for some other things as well. So they want to have their own internal audit standards. And custom profiles really allows you to build these extra checks in. And all we have to do is we go to any one of these standards that we like, and we might say, okay, we'll take something from PCI DSS. Let's say we want to specify something to do with syslog. That's always a good example. So configure remote logging for ESXi hosts. Maybe we want to specify that this is going to be our syslog server, and we want to check against that for everything. But this check isn't in the DSysTig check. So all we have to do is we go copy to custom profile, and we'll copy it to a specific custom profile that we've created. And then we can change the severity if that's what we want to do. But yeah, we can put all this in here. We can give it a new title. We hit copy issue. And then now what we're going to see is under this custom profile, we're also going to be checking against that specific syslog setting that I've just put in there. So that's all in there. So it's just another feature. It's not specifically related to Kubernetes, but I wanted to just mention it during the demo. And that is we're kind of wrapping up at this point. We've got about 12 minutes left. We have had a few questions in. So the first one, how does Runecast simplify Kubernetes management? And I mean, hopefully, we've covered that over the course of the webinar. But what we're aiming to do as a vendor is provide you really, really good insight into what's going on in your environment. We're trying to help you to be more proactive about making sure that you know that you're abiding by best practices. And as those best practices evolve and change, then we're going to provide you with the latest data. So just because something was best practice 2 years ago does not necessarily make it best practice now. So we're going to help you see all of these things as the industry evolves. We've covered how to connect Kubernetes to Runecast, and from an analysis perspective. So the analysis is super, super quick. So in terms of, it's going to depend on how many nodes you have, and if you've got vSphere in your environment, how many vCenter servers, how many ESXi hosts you've got in your environment. But we scale really well. From that perspective, we have from a config analysis perspective, we've got a customer in Europe, and they run something in the region of, I forget the exact number, it's something 14,000 ESXi hosts. They manage all that with a single appliance, and the scan time, it takes a little while, but you only have to do that scan periodically. And once you've done that scan, you can kind of build up this historical data as to what's going on in the environment. You can see when you start to drift away from a compliant baseline. We've also had a bunch of questions from one person, actually. So the first question was, does Runecast also support Azure and GCP besides AWS and VMware? So the answer to that is not as yet, but watch this space. Azure will be coming in the new year. GCP will be coming after that. Next question was how, in fact, if anyone else has got any questions while I'm working through these, please do send them in, and I'll be happy to answer them there. How is Runecast deployed? Is it SaaS? Is it a container? Is it a virtual machine or a physical appliance? So I might have answered that since you asked that question. But at present, Runecast Analyzer is deployed as a virtual appliance. It's a super lightweight virtual appliance. You know, in terms of sizing, we start at 2 vCPUs, 4 gig of RAM, and you know we scale up beyond that. Depends on the size of the environment, but it's super lightweight. It's super quick. That's what we want. That's where we want to be going. We're working on potentially the capability to deploy into a native public cloud, and also potentially as from a container perspective. But as is always the case with these things, anything could happen between now and some distant point in the future. So by all means, if you want to learn more, if you hit us up, there's an email coming in the next slide. We'd be more than happy to add you to the mailing list, and you know, if you need any more information, we can definitely go down that route when we get to that point. There was a question. Where are we? Let me just expand that one. How is Runecast licensed if containers are in both on-prem, e.g. vSphere and AWS? So the container model, and I'll put my hands up here and say I'm not a salesperson, so I might get this wrong, but hopefully I've got a good enough steer on this. So from a Kubernetes perspective, the way we're looking to license is going to be based on the number of nodes that you deploy. So the number of kubelets, essentially. So the number of nodes that you have is the number of licenses that are required. So in terms of, you know, if you're running an EKS, if you roll your own Kubernetes on EC2, you still need to have, you need to deploy a kubelet to that node, and that's how we would license it. Next question: does Runecast support only Kubernetes? How about Docker Swarm and Mesos, Apache Mesos? So as things stand, again, at the moment, it's, you know, Kubernetes is what we've gone to market with. That's the technology that a lot of our customers have asked about. I'm not sure about plans for Docker Swarm or Mesos, but you know, we're in a fast-moving industry, so you know, if there's demand, then I'm sure we would go down that route. But yeah, as things stand at the moment, as far as I'm aware, there is no plans support for Docker Swarm or Mesos. Finally, do you intend to prepare Helm for Runecast to be able to use not only OVA but Docker directly? Tom, do you know anything about that?
I know we have plans. You already maybe mentioned that with the type of deployment. Currently, we have OVA, as you said, and as Peter asked. But we are planning to move more to container world, and we'd like to be able in the future to deploy in the containers. So I think Helm will be a logical way of doing that. I'm not sure about Docker directly, but it's planned to have deployment for Kubernetes.
And just for people who don't fully understand the technology, like myself, Helm is like it's kind of like a package manager for containers, right?
Yeah, you can call it like that. It's more like a package manager for Kubernetes that is allowing you to deploy application with some prepared templates. You just fill in required information that are specific to your environment, and you are able to deploy the application with one command.
So we did have one more question, which was: is there any performance measurement from inside Kubernetes to see how performant my cluster is? So in the interest of full disclosure, we're not really a performance monitoring tool. It's not something we're looking to do. However, you know, that's not to say that that's not a thing that we would do in the future. Once we kind of get to a point where we have this kind of agent-based model, so we can pull this information directly from the kubelet, I think, you know, there's potential for that. But as things stand at the moment, that's not it's not a key focus of what we do. So on that note, I'm going to again play the "Where Has My Mouse Gone" game. What's going on with my machine today? And I'm just going to wrap this up. So if you're interested in learning more about Runecast Analyzer, please do visit our website at runecast.com. We have a free 14-day trial, so you just download the appliance, deploy it into your environment. You don't need a license key or anything. It will just give you the that information for the first 14 days. If you want to learn more about Runecast Analyzer, if this is really kind of whet your appetite, then we'd love to organize a full deep dive into the product. Obviously, I've only touched very, very lightly on what we can do for Kubernetes, and even lighter on what we can do for everything else. So please do email us at innovate@runecast.com, and we'd be more than happy to set up a deep dive with myself or one of my colleagues. So on that note, I just wanted to say a big thank you to Tomáš. Thanks for joining us on this this session. Hopefully it wasn't too nerve-wracking for you. Thanks to everybody else who's joined. I see we've had a great number of people in on this webinar, and anyone who's catching up, again, I hope this has been useful to you. But on that note, thanks very much, everyone. Bye bye.
Thanks for watching. Bye bye.